We have arrived at the last module of the textbook, and this one, module 10, is all about statistics and stuff, with lesson 1 dealing with statistical questions. The textbook claims this is a single-day lesson, and they only have 9 resources for us, so I'm hoping to knock this out in a single video today. On a busy day, the wait on a popular ride at an amusement park can be hours long. Some amusement parks allow guests to save a spot in line by reserving or purchasing a special pass. Disney did that a while back. Don't know if they're still doing it or not. This lets the guests go right to the front of the line whenever it's turn. Must be nice. Particularly considering you had to stand in line for like an hour and a half for some of those things. Crazy. Anyhow, Brady does not have a pass and wants to know how many minutes he can expect to wait in line for the new roller coaster. He surveys a group of people who rode the roller coaster about the number of minutes they waited. How can surveying people who already rode the roller coaster help Brady? These are the kind of questions we're going to be talking about. Now, if Brady went to a really good quality theme park, he would have just known he could look right up over the people, and there's a little light up sign there that says how many minutes he can expect to wait from various points while he's standing in line. But you know, Brady, I guess, just isn't that observant. We're going to start off with a couple of new definitions here for us. The first of them is statistics, which involves collecting, organizing, and interpreting pieces of information or data. This is a huge business in mathematics. Lots and lots of people make lots and lots of money working in the field of statistics. One way to collect data is by statistical questions. A statistical question, here we go, is a question that is answered by collecting data. So you have to ask people or research something in order to collect your data. Answers to statistical questions will vary based on the data collected. The table gives some examples of statistical questions and examples that are not statistical questions. So, a statistical question: how many texts do middle schoolers students typically send each day? That's a question you could ask people and get answers from. Not statistical: what is the height in feet of the tallest mountain in Colorado? There's only one of them. It's Mount Ebert. It's about 14,000 feet, I believe. It's the tallest of the 14ers in Colorado. It's also very pretty. It's right over Twin Lakes, but you know, I have digressed again. A good statistical question: how many hours per night does the typical teenager spend watching television? These are things you could ask people. However, how many people attended a jazz concert last night? That is an exact number. That's not something that you can actually survey people to get different answers for. Real simple, statistical questions, your answers are going to vary, while non-statistical questions, there is one solid answer that goes with them. In the table, the questions on the left side are statistical questions. Wow! Because if you were to survey a group of students, you would get a variety of responses. Variety, vary, didn't I say they vary? The questions on the right are not statistical questions because each question only has one valid answer, just like I said a moment ago. The next slide wants us to work on constructing statistical questions. I challenge you to say that 5 times really fast. It says, constructing statistical questions is an important part of the process of using statistics to collect, organize, and interpret data. And you're going to learn how to apply these steps in order to help answer each statistical question. First step in doing it is going to be to construct the statistical question. You can't very well ask a question if you don't know what you're asking. The next step is to use the question to collect data. In other words, ask the question to lots and lots of different people. The next step is going to be to summarize the data using graphical displays or tables. Means you have to put your data you collect someplace so it can actually be interpreted so you can understand it. And finally, step 4 is to use the data to answer statistical questions. In other words, based off the data that Brady collected with his roller coaster ride, how long could he expect to wait in order to get on that puke machine? For example 1, they're asking us to determine whether or not each question is going to be a statistical question, and it says to move through the slides and determine whether or not they are. First off, how many states are there in the United States? Is it statistical or not? There's 50 of them, always 50. Since 1948, I think, is when we brought 50 something. We brought Hawaii and Alaska in. Since we brought those in, it's been 50 states. Not a statistical question. Until they change the number again, it's always going to be the same. All right, let's look at another one here. This is not a statistical question because it does not anticipate a variety of responses. There are 50 states in the United States. Very good. Next question. How many states has a typical middle school student visited? That is a totally statistical question because we could ask each person in our class how many states they've visited in order to create a survey. So yes, that one does qualify as a statistical question. The next question asks, in how many states has a typical adult in your neighborhood lived? Once again, is that a question that is going to get a variety of responses? Absolutely it is. Therefore, it is going to qualify as a statistical question. And let's see, what's our last one going to be? In what year did Alaska become a state? Maybe they're going to answer our question from a minute ago. It is not going to be a statistical question because that was only 1 year that it occurred in 1959. See, I said it was in the 1950s. Easy math, y'all can do this. Just ask your question, does it have one answer or does it have a variety of answers? That will be the determining factor on whether or not it is a statistical question. And that takes us to extra example 1, where you get to take and answer the questions about whether or not they're statistical or not. It says to drag and drop each icon in the appropriate bin to identify if they are going to be statistical questions or not statistical questions. You guys go ahead and pause the video and work on this now. So how did you do? Let's take a look. How many people attended the most recent Olympics? That's going to be a not statistical question because there's only going to be one answer for it. How many baseball games were played last year? Once again, there's an exact answer, so it's going to be a non-statistical. How many minutes per week does a typical student exercise? Well, most of y'all, that's going to be 0. I mean, let's own it, folks. But it is going to vary because we do have some football players, some basketball and volleyball and whatnot, and some people that just like to run because they're crazy. And then finally, how many musicals did the middle school student typically attend last year? Once again, the answers are going to vary. Most of them are going to be none, but there are those people who like to sit there and have other people sing at them. Now for our next learn, we're going to learn about displaying our data on a table. It says a survey is one way to collect data to answer a statistical question. Once the data are collected, you can record the results in an organized way, such as a table, in order to analyze them. Suppose a random group of adults were asked a question, how many hours do you exercise a week? Guess what? Adults don't really exercise either. I do. I'm special. The results are going to be shown on the table. So down here, if they ask how many hours, let's zoom in a little bit. They had one person said 0 hours. You had a whole bunch of people here lie. You had for 1 hour, there was 2 people. For 2 hours, said 5 people. 3 hours, said 5 people. 4 hours was 3 people. 5 hours was 1 person. And then you had these nutcases that exercise 6 hours a week, and there was 2 of them in there. Based on the results in the table, one observation you can make is that more than half the people who responded exercised fewer than 4 hours a week. How do you get that information? Well, how many people responded? We got 1 plus 2 is 3. That's going to give us 13, 16, 17, 18, 19. So 19 people responded. And if you took the halfway mark, which is, the 4 hour mark, so we're looking at these groups right here. That's going to give me 10, 13. So 13 is more than half of 19. So we could say that More than half of the people did indeed exercise fewer than 4 hours a week. For example number 2, suppose you want to answer the statistical question, how many hours per week does a typical 6th grade math student study? Yeah, I'm giving you that look. You survey students in your math class using the question, how many hours do you think they typically study each week? The response were 2, 4, 5, yada, 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 all the way through this one right here. And they want you to take and organize that data into a table and then analyze the results. So, how many columns are your tables going to create or going to need to have on it? Well, I'm thinking you're going to need to have one column for each number of hours. You got 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and 6 hours. So I think we're going to need 6 columns. Let's see what they say to do. Organize in the table. So actually they did 2 columns and 6 rows here. So they had 1 column for the number of hours, 1 column for the number of respondents, and then from there we're going to look at our data. How many people did 1 hour? Well, we had 1, 2, 3, 4, 5. So 5 people said that they studied for 1 hour. How many people did 2 hours? 1, 2, 3, 4. How many people did 3 hours? That's 1, 2. How many people said they did 4 hours? That's 1, 2, 3, 4. And then we get up into the super studiers. 5 hours is 1, 2. And 6 hours for the student that's just really going to go places in life. There's only one of them. Check our answers. And wait a minute, did I miss something? I didn't miss something. Hold on. Alright, I was a goober. That should be a 1 there, not a 6. I'm talking and not paying attention. The 5 is going to be a 2, which is going to be right there. And then, what else was wrong? 3, yep, 3, I did the same thing there again. So the 3 actually should have said 2 hours. I guess I need to pay more attention to what I'm typing in and less attention to what I'm speaking in. Now the next part of this problem is for us to analyze the data. So they want us to take and start off by finding the total number of students surveyed, and when you add all that together, that's going to give me 9, 10, 18 students were surveyed. That part checks. And then now we've found the total number of students surveyed, we can use that to determine some information about it. So the study the responses to determine if there's an overall trend. Make one statement that you can make is that more than, exactly, or less than half of the students who responded studied fewer than 3 hours. So fewer than 3 hours, well, that means we're only looking at this category and that category. 5 plus 4 is 9. 9 is going to be exactly half of the 18, so the correct answer is that exactly half of the students studied fewer than 3 hours. Now, we did not include the 3 in because that would be less than or equal to 3 hours. And if that's the case, then we would have had a totally different answer going on there. And now we're on the last question in this lesson, this extra example 2. Go ahead and pause the video and work it on your own. How did that go for you? Let's see what I do. The question says, suppose you want to answer the statistical question, how many pets does the average middle school student own? You survey your classmates using the question. Well, if you're in my house, let's see, we got 1 dog, 2 cats, that becomes 3, 1 dragon, that becomes 4, and then we have 3 ducks, that becomes 7, and then a goose. So we have 8 pets at our house. Yes, we really have a dragon. True story. The responses to the questions were given here, and from there we want to organize that into a table. So how many students said they had 0 pets? That's 1, 2, 3, 4. 4 students said they had 0. 1 pet was 1, 2, 3, 4, 5, 6. That's going to be 6. Don't forget this little 1 over right here. That's a one student too. Okay. And then 2 pets was 1, 2, 3, 4, 5. Put in my 5 right there. 4 pets was going to be 1. Just one person has 4 pets. Wait, did I lose 3 pets? Where's my 3 pets at? 1, 2 families have 3 pets. And then, wow, we got to go all the way up to 7. So we have 5 is going to be next. So in the 5, I've got, nobody said 5. And since nobody said 5, that's going to be 0 people have 5 pets. 6s are going to be 1. And 7s are going to be 1. So I'm going to put down a 1 and a 1. I guess people aren't as pet crazy as my family are. And how did I get wrong on my 4? Let's count that up again. 1. Oh, I did the same thing I did in that other problem. I was speaking instead of typing. So there, all that part's good. Now, more than half the students responded own how many pets? Well, first off, how many students responded? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So a total of 20 students responded. The question says more than half. So we need to have more than half of 20. That's going to be 10. So we need more than 10 students responded. Say they own how many pets? Well, let's add them up. We have 0 and 6 is 10. And then so we would actually end up having to go to 2 pets or less, I believe. There you go, 2 pets or less. Well, let me look at that one more time. Did I miscount my people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, there's 20 people there. And it does say half of 20 is 10. More than half of the students responded own fewer than 1. Nope. Less, 3 or less, 4 or less. Well, what does it say there? It says 3 or less, and that doesn't make any sense because half of 10, yeah, their answer's wrong. It should be 2 or less on that one. Anyhow, that's going to be it for the lesson. Get started on your homework, please.